Hey, what's up guys, Totally Dubbed here, and today I'm going to give you, well, try and explain several things in terms of overclocking your PC. Now, first of all, I want to say I'm not an expert on PCs. I can't give you technical details on certain aspects of a PC, nor can I try and explain you how certain things work on a PC, as in the internal things that happen within a PC. This guide is actually representing Swag's guide on overclockers.net. His guide helped me overclock, and he is very knowledgeable on the subject, and I thought to create a video because a lot of people would like to see it rather than read it or be explained it all the time. So I'm going to go through several things about overclocking your PC and an explanation of certain things. So first of all, I want to say I'm on 4.5 gigahertz overclock with a stable 1.27 voltage as my core voltage, with an offset of plus 0.070. This is a stable rig, 24/7 folding rig. I'll explain folding in a little while, and it works perfectly. So first of all, I said those things and you're like, wait a second, your CPU's edge is showing something else, don't try and lie. Well, yes, I'll just get to that in a second as well. Another thing I want to mention is that initially when I started overclocking, I didn't realize, but I had a hardware fault on my RAM, which caused a lot of problems, and I will explain some stress testing methods that you should use before overclocking, simply to determine that everything is working out the box. Another thing I should mention is that my i7-3770K is de-lidded. De-lidded is when you take the CPU, and this is an old Pentium 4, if you take the old CPU, put a razor or a hammer and get rid of this IHS, this is called the IHS, the silver bit with the smiley face on it, and this green thing is called the PCB, is when you remove that and change the thermal paste within under the IHS and on top of the die. The reason people do this, especially on Ivy Bridge processors, is because the distance between the IHS and the die can be reduced, and when it's reduced with the right thermal paste, which is CLU or CLP, you can get better temperatures. The temperatures I got were around 20 Celsius drop on full 100% load whilst folding. So it's a huge difference for me, and that's why I de-lidded. So my temperatures will not reflect your i7, which is just your stock i7. However, if you've de-lidded, it might be more realistic. So let's get into overclocking. So first of all, you want a processor that can be overclocked. You can look around on the internet for overclocking processors. In this case, I've got the i7-3770K. Now, I mentioned the K there because it's the unlocked version. It's almost Intel wants you to overclock even though it avoids your warranty. That's another thing that I should mention, is that when you overclock, and if you fail at overclocking and burn your CPU, Intel will not grant you your warranty because you went outside the factory specifics and factory what it came with, and you modified it and you ruined it. So if you overclock and fail, which is extremely unlikely if you follow this guide and read guides on the internet. However, it is something to bear in mind and always to mention. Another thing is cooling. Now, cooling is a huge part of overclocking. As you can see, I've got core temp here, which gives me my real temps right now of my CPU. So as you can see, my CPU is running between 24 and 30 Celsius on the different cores. The core temperature between cores will vary, and the explanation behind this, and thanks to several forum members for pointing this out, is simply because of where the cores are located on the die. On a CPU, especially the Ivy Bridge, the core, the die is positioned like this. Imagine like that. My finger is the die, and certain points you've got 4 different cores, and the different cores reflect where the other components are on the CPU. By that I mean you've got iGPU, which is something quite big on the i7s, which was quite pushed, and it's getting pushed onto Haswell, which is a next generation of processors coming out by Intel. When the iGPU is used, obviously that's using some voltages, and because of that it's creating a hotter core. So one of your cores might be hotter than the other one. So it depends where the core is located, and that will reflect the temperatures. I presume my core 0 is the closest one to my iGPU, and the core 3, or should I say core 4, is the one which is closest to maybe my RAM, my IMC on the CPU. IMC is the internal memory controller, and an internal memory controller communicates with your RAM, which is, you know, your physical RAM on your which you've placed on your motherboard. So it just depends. So if you've got a variance between these cores, it's quite normal. I have seen quite a variance, especially when I have full load, and the full load is between 10 to 6 Celsius between the cores. By that I mean core 0 is almost always about 6 Celsius cooler than the rest of the cores. So don't be afraid of that. However, if you notice a bigger difference between these cores, as in if we're looking at over 10 Celsius to 15 Celsius of core difference, there's something wrong with your TIM application. Now the TIM is the thermal paste that you use on your CPU. If you notice that when you have a CPU, you put thermal paste over here where the smiley face is, and you put a cooler on it. If you have uneven application, let's say you've just covered this half but not this half, by that I mean when you put the cooler on it, didn't place it correctly, it might mean that you have a higher difference between the cores because the thermal paste hasn't been applied evenly. So do make some tests with that. In terms of coolers and thermal paste application, my honest suggestion for Ivy Bridge is a very, very thin line across there, just across there. So that's where the die is sitting, just a very thin line. However, this depends between people, and I highly suggest experimenting between this. You can use the mini pea-sized method, which is literally a little dot in the middle, and when you press the cooler on it, it spreads it pretty much like a circle. However, I found the line method works best with me with my cooler because it gave a nice square application, and that's because of me testing it and looking at temperatures and temperature differentiations, and also or should I say variances, and also the application physically on the CPU. In terms of coolers, so I was speaking about coolers there. Cooler is very, very important. If you plan to be overclocking, get rid of that Intel cooler. The Intel cooler is great for stock voltages and stock clocks. If you go over that certain limit, you might well burn your processor, so do be warned with that. It's very, very important. I can't stress this enough. Get a good cooler in order to get a good overclock. The higher the overclock, naturally, the higher the voltage, and the higher the voltage, the higher the temperature. So do bear that in mind. What you want to do and what you want to try and aim at in terms of an Ivy Bridge processor, because each different types of processor have different limits, is you want to be under the TJ max. As you can see on core temp, we can see a TJ max of 105 Celsius. 105 Celsius is the TJ max for Ivy Bridge processors. Realistically, you do not want to be going over 95 Celsius on full load. Full load is 100% usage of your PC. As you can see, I've got only 2% or 0% usage of my PC. When this cranks up to 100, you don't want these cores going over 95. The reason I say 95 and not 105 is that it gives you that 10 Celsius leeway just in case, for any sort of reason. To test temperatures, we're going to use several stress testing methods, and I will show you them in this video. So do bear that in mind. You want good cooling, and you want a good TIM application, and you want to make sure that you're monitoring these temps when you're overclocking. So what I'm doing here is trying to show you the basics of overclocking before actually overclocking itself. The reason we want to do this is because we want utter safety. If you pass TJ Max, for example, you might burn your CPU. If you have uneven TIM application, these temperatures down here won't be reflecting on your true temperature that you could be gaining. So do bear that in mind. So as I said, I've got the i7-3770K. It's running on a Asus Z777 Sabertooth. It has Corsair Vengeance RAM in there. It's only got 2 of them, so it's 2 times 4 gigabyte modules, which make 8 gigabytes in total. The reason I have 8 gigabytes only is because I see no need to have 16 gigabytes. I actually donated 2 of my RAM sticks on my mum's PC build that I built for her because I would never use more than 4 to 5 gigs of RAM ever. As you can see on idle, I'm using 2 gigs of RAM over here. However, normally I wouldn't ever pass 4 to 5 gigs. So that's one thing. Now the cooler that I'm using is the Antec 920. It's also got 2 fans on it. It's the Corsair SP120s on quiet mode. It is on a pull-push configuration. When they say pull-push, this is the radiator. It is pushing air through and then pulling air through. And I've got them taking air from the outside of the case and bringing it inside of the case. If you do this type of method, make sure you have an exhaust fan. The exhaust fan is when air, if this is the case, imagine this is the top of the case, hot air is coming in through your radiator and through your through your fans. You don't want hot air to be floating around in your case, so you need an exhaust fan. So in my case, it's at the top, which takes air out of the case, and that is your exhaust fan. You want to make sure if you do that, you have that, because or else you don't. When you have hot air floating around, it'll mean hotter components and hotter components basically. So there you go, guys. That's my build and that's my overclock. Now let's get onto the guide. So you can see it took over 12 minutes just explaining you certain basics of overclocking, and by basics I mean simple things that you need to do before you start. So I just want to show you one thing before we go into my BIOS. First of all, I want to show you my RAM. Now my RAM is the Corsair Vengeance 16 gigabyte, as I said. Here is the model name over there, and this is off the Corsair website. Now the reason I'm showing you this is a few things. As you can see, I had the 16 gigabyte kit. As I said, I'm only using 2 of the sticks. And the reason I want to show you is this. Tested and SPD voltage, speed ratings, SPD and tested speeds, and tested latency. These are very important because when we go into the BIOS, what we're going to do is input these values. Now, the tested voltage is 1.5 volts. Because I had 4 sticks, what I thought is that it would be better to add a little bit of extra volts. So I put 1.55 volts on my BIOS. What you want to make sure is that you never exceed 1.65 volts on your voltage for your RAM. Do not ever exceed 1.65. Some manufacturers will have 1.65 of tested voltage. That's fine, put it on, but don't exceed that unless you know what you're doing. Speed rating. So it's 1600 megahertz RAM, as you can see there. However, the SPD speed is 1333. 1333 is what defaults when I hit the F5 button in my BIOS. The reason behind that is because it works on every single board at 1333, but it can run at 1600, and it's been tested at that rating. The latency is also important because here we've got 99924. There's one other one missing here, which is the command rate, but what you want to make sure is that this tested latency matches what you've got in the BIOS, be it via the XMP profile settings, which is basically the automatic settings that your board will pick up and input in your BIOS, or if you're doing it manually like I have done and put 99924. The command rate is also another important thing. The lower the command rate, i.e. 1, the better the RAM speed will be. In my case, mine was a 2N, which is pretty much regular and standard. It's not super fast RAM. It doesn't really matter. It's a 2N command rate, and you'll see this inputted. So first of all, as I said, you want to check the specs, the exact specs off the website, or off the sticker of your RAM, off the sticker of your box that you got with your RAM, to check what are the tested speeds for RAM. Is extremely important, because if you don't get these right, you might not ever be stable because your RAM settings are not right. And you'll see why, because we're going to be testing RAM as well as CPU, because the IMC, which is located on the CPU, the IMC is normally located on the right hand side of the CPU, communicates with the RAM, and if you've not got the right amount of voltage of on your CPU or your RAM, it will mean that your communication between the two is not good, and therefore you will never be stable whilst running stress tests. So that's quite important. Another thing is programs you should get. Now, programs you should get, there are several. First of all, there's Core Temp. I personally like Core Temp for monitoring temperatures. You need something like this. You do not rely on AI Suite 2 or any crap like that. Get Core Temp or get Real Temp. Those are the two programs that I trust in terms of monitoring temperatures. I should also mention that software is normally not to be trusted, but these are the best softwares we can get for free, and most reliable ones that have been tested, throughout the world with overclockers in terms of getting a good reading. So in other words, when it says 26, in reality it might be 25.85 Celsius, who knows? But the only way you could test it is actually with, well, you actually can't, because you can't actually see it. But anyway, the point is, volts, for example, which are monitored over here, cannot be realistically exactly and correctly be monitored via software. If you had like a voltmeter, for example, you could actually test what the amount of voltage is actually going into your CPU and things like that. But anyway, these are the best softwares to get. So CPU-Z is what you'll need, Core Temp, and Real Temp. You will also need Prime 95, which can be found over here, and get the latest version of Prime 95. You'll also want Intel burn-in test, which is quite useful for short-term stability testing. And you will need Task Manager, which comes free, obviously with your Windows system. So there you go. So those are the softwares that you're going to need and that you're going to want to get. Also, other recommended softwares can be HWMonitor, which I don't have on my PC. That is quite useful for checking, again, the same thing, the voltage and the temperatures. And also you could use, I'm just trying to look for the, where is it? Trying to look for the application that's on my mind, but I can't actually remember it to think of what I want. But anyway, it doesn't matter. It'll probably come to my mind when I'm rebooting, because I'm an idiot like that sometimes. But yeah, those are the applications you want. Now finally, when I said, hey, look at the voltage, look at the core speed, you're lying about your 4.5 gigahertz. I'm not, because I'm on balanced power state on Windows Power Options. Windows Power Options can be found via the control panel. If you go on control panel, oh, I hate this thing, small things, small icons, and you go to power options, you'll be able to see power states. Now, power states are actually important when it comes to overclocking, because on balance, as you can see, when not in use, I'm at 1.6 gigahertz. It says 1600 megahertz. If I launch Prime 95, which I will just do now really quickly, just to show you guys, check this speed over here. There you go, it jumps up straight to 4.5 gigahertz right there, as you can see. Can you see that? Good. So that just shows you your how Windows works with your power options. So this was on balance. So when on balanced, it'll throttle down to 1600, so 1.6 gigahertz. There's also C states that we're going to have to enable in the BIOS in order for it to do that. As you saw also, when I went up in voltage, over here, up in core speed, my voltage went to 1.3 volts when I said my voltage is on 1.27 volts. I'm going to explain that after when it comes to folding, because basically different applications, well actually I'll explain it now, different applications, stress testing applications require different things. So even though I'm on a 1.27 manual, my actual offset is plus 0.07. The reason behind this is because when I was folding, and folding is basically you donating your computer processing for research. As you can see, I'm going to launch folding at home right now, and it's going to launch some load. As you can see right now, my voltage is at 2.8 or 2.9 or something like that. That's because that's the offset that I needed in order to get a stable overclock. Plus 0.07. However, when I was prime testing, I needed only plus 0.04 offset. I will show you this in the BIOS, maybe it'll make more sense when I'm trying to explain this, but basically the reason behind that is because I was not getting enough voltage whilst on offset when I was folding, and as I fold all the time and I don't prime 95 every day, it means that I need to have the right voltage for the right thing. So these are the certain things that you should bear in mind. Also, I should say that if I go on high performance, it will automatically go to the rated core speed. I'm folding right now, so let me just stop folding, and it should drop to 1600, just to show you this balanced and high performance thing on Windows, which affects core speed. There you go, it's folding stop. So as you can see, 1600 here. If I hit high performance, it should bump it up to 4500. Sometimes it might take a little while, but I can guarantee you when you go to high performance it bumps it up. Just to check the plan settings. Oh well, high performance is not actually high performance. High performance normally has this. Bam, as you can see, 4500. High performance has your minimum power state as 100% and your maximum power state as 100%. In other words, it's always running at 100%, i.e. 4.5 gigahertz. If I go to balanced, you'll be able to see the difference over here. It's 5% and 100%. So I go on balanced because there is no need for your processor to be constantly running at 4.5 gigahertz. If there is need for a process, your processor will seek it and therefore bump up this to 4.5 gigahertz. For example, when you're gaming, when you're folding, whatever, when there's load which is put on the CPU, it will bump this up. So I suggest going on balanced power state. And actually another thing that I probably should have mentioned, and this is unrelated to overclocking, is that on balanced, what I usually do is change the hard drive sleep time to never. Usually this is on 20 minutes. The reason I put it to never is because I want a very responsive hard drive no matter what I'm opening. And as I use my external hard drives quite a lot, I want that as never. So that's my only suggestion on the balanced power state. That was just an FYI. Right guys, so what I'm going to do is boot into BIOS and I'm gonna create a second video. So this is going to be part 1 and there's going to be part 2. So the part 1 was looking at softwares you need, physical hardware things that you might need, for example coolers and TIM applications, softwares, stress testing programs, for example Prime 95 in Intel burn-in test, how to monitor your temps, a little explanation of voltages and core speed, especially when it comes to increasing load and offset, and your Windows power options. So tune in for part 2 of this overclocking guide.